Hi, Will. Welcome to the Autoware Podcast.
Yep, thanks for having me.
You are our second guest since we very recently started it, but it's very exciting to have you here. We are doing this. We actually decided to start the podcast because we will have very exciting demos and at the CES 2024. And we also have the inauguration of the simulation racing. Let me say just the restarting of the simulation racing in partnership with the Indy Autonomous Challenge and Autonoma Labs.
hmm
So before getting into the discussion, can you let's get to know you a little bit and Autonoma Labs, of course.
Yep. So I'm Will. I'm CEO of Autonoma, and basically our whole mission is to make autonomous that is through really cutting edge simulation tools and development tools to help out developers as they test, their and validate the safety of their autonomous systems against a really wide range of scenarios and edge cases.
Great. And you're based in where?
We're based in Auburn, Alabama. If you're familiar with the area, it's near the university is our main office.
Okay, perfect. And so, as I mentioned, the simulation racing will be a part of the CES 2024, and Autoware Foundation worked with Autonoma Labs to integrate the simulation racing with our open source simulation platform called AWSIM. So Autonoma Labs pulled in the weight and did the integration work there for creating the vehicle, importing the vehicle dynamics of race cars, creating the track assets and everything. And I know that you are a former Indy Autonomous Challenge contestant, right?
hmm
Which university were you with
I
previously?
was with the Auburn University team, so autonomous tiger racing, and I competed in the IAC from the very beginning. I think starting in January 2020, all the way through the first two real races at Indianapolis and Las Vegas in 2021, 2022.
Okay, so you are the right person to do this job basically, and I have seen the work and everything. We will also show a very quick glimpse of what you have done at the Autonoma Labs for this work. But before getting into the actual progress, let's talk a little bit about the sim racing
hmm
because in the autonomous challenge is really fascinating. We actually met at Monza racetrack as a
hmm
part of the one of the events from the Indy Autonomous Challenge, and these Dallara AV21 race cars are racing, and they are setting new speed records. They did
hmm
at Monza, right?
Yeah, pretty much every event they've had, they've continued to push the boundaries and set new records as far as speed and performance.
That was really nice to see the vehicles, but those vehicles, as far as I know, quite expensive, and there are only so many available, and
hmm
that kind of limits the number of contestants in that competition, right? So the simulation racing is kind of like a solution for that. Maybe we can talk a little bit about that one.
Yeah, absolutely. I mean, the real cars, they're amazing machines, but I think the total price or value is around $1 million, and it's really beyond a lot of teams' abilities to be able to raise the money to buy that. And on top of that, even if you can, there's only 10 cars, and so they're pretty much all accounted for. So new teams that are really looking at joining the IAC or getting into autonomous racing, the opportunities are limited, and so by relaunching these sim races, we're really allowing for a lot of these universities that want to find a way into the IAC to be able to participate, to be able to do the same kinds of events, to race head to head against other top universities from around the world, and do so in a way that's really accessible to anyone.
So for the simulation racing, the university teams are enabled to use the AWSIM with the integrated parts from the Autonoma Labs, and like how does it work? I knew that there were going to be practice rounds, right? So how do they use a simulator for the university teams? And maybe also you can tell us what kind of attention you've got for the simulation racings.
Hmm. Yeah, well, I mean, just the basics of the simulation, it's based on AWSIM, but we had been working with the teams since our founding in 2022 to create a really accurate digital twin of the vehicle, both the dynamics, the sensors, the environments, and the interface. And so by partnering with Autoware Foundation, we've taken that we've developed, we've integrated that into the AWSIM platform, and then we're providing that to the teams as a resource both for their testing and preparation for actual events and also these sim races. And so for the sim races in particular, we actually create competition version of the simulator that's an executable that we provide to all the participating teams that have registered. And in that, it restricts all the teams to use the exact same setup, the exact same sensors, so it's fair across the board, just like the real competition is. And so, what teams do are they for the first two practice rounds, they're really running their simulations in their own time asynchronously. So for the first practice round, it was a time trial, very similar to what you and I saw at Monza in June. The teams are trying to set their fastest flying laps. And so they can practice as much as they want, but when they go into compete mode in the simulator, they get one warm up lap and two flying laps to set the fastest two laps possible. And the simulation tool automatically generates an encrypted log that they then submit to us so that we can verify that they didn't break any rules, go off track, anything like that. And we are able to post process it and figure out which team is the winner. And so the second practice round is really moving towards the goal of head-to-head multi-vehicle racing. And so as a stepping stone to that, it's a very similar format. It's still one warm-up lap, two flying laps, best time wins. But this time there's AI opponents that they have to overtake on track. And the other interesting part is as they overtake each opponent, the next opponent that they come up with is higher difficulty. It's a faster car, more difficult to overtake. And so it's not just repeating the same thing, but it gets harder and harder as they go. So we're really excited to see, which teams come out on top, especially now that we're moving towards that multi-vehicle racing.
And there are some teams already experienced at the IAC, and I've heard that also there are some teams just beginners and newcomers, right?
Mm-hmm. Yeah, absolutely. So a lot of the existing IC teams, or most of the teams, are participating in it, and obviously we expect them to do well because they've had a lot of practice, and with the tracks and the sensors and the vehicle having the exact same interface and dynamics as the real car, they're able to translate all of that directly into simulation. But one of the things we've been really surprised and happy to see is many of these new teams that have registered that aren't part of the IAC, probably more than half of the teams competing, some of them have really been able to put in really good performances and have really fast laps. The after the first round, the top two teams were existing IAC teams that we've seen win championships and win prizes before. But the next three or four teams were actually some newcomers that are really getting into autonomous racing, whether through IAC or other organizations, and they were able to put in really, really good laps and good performances. And some of it was really a photo finish. Between the top two was less than a second, and between I think third place through sixth place was less than a second. And so we really had very close performances amongst existing and new teams. That's been great to see.
I really didn't know the progress with the practice runs and everything to this extent, really. And by the way, I will of course share some kind of details about the website that is also explaining on the Indy Autonomous Challenge website the practice runs, and then at the CES 2024, there will be also an inauguration event, right? I know that the exact details are still work in progress, but tell us a little bit about what can we expect to see at the CES, and then we
Hmm.
can also dive into how Autonoma Labs worked with Autoware Foundation to do all this integration with the AWSIM after that one.
Yeah, so these first two practice rounds I've talked about, we're building the foundational blocks of multi-vehicle racing. So the third practice round is really where we're going to have head-to-head racing. It's no longer a team versus multiple AI. It'll be teams all racing against each other, and this really allows teams to push the boundaries even further. And there's a lot of benefits of simulation compared to the real world testing as far as being able to really test the performance without the consequences that you have in the real world. And so, what we're going to see at CES is kind of the culmination of these three practice rounds. It'll be multiple teams racing head to head in the simulation and seeing who comes out on top. And so, depending on how teams do in these practice rounds, in which teams qualify to compete, we may see one or multiple heats of teams competing to see who's the fastest overall head to head.
Yeah, that sounds very exciting, and it also sounds like everybody will be on the edge. Teams are going to race head to head. It sounds very, very nice. Let's just go to the a little bit more technical details, what you have done for the AWSIM integration. And at this point, I would like to share a few things. Let's put a visual context to it so the people also, the viewers, can see how nice it looks. So there we go. Okay, so this is your repo on GitHub, and I will also share the link with the viewers when we announce this podcast session. And you have prepared a nice documentation here. I'm pulling that up. And before going and asking about the specific parts, let's just go here and admire the nice looking views of the Monza track here. This is the Monza track, right?
Yes, yes.
Yeah, the Dallara AV21 vehicle we are seeing here, the track we are seeing here, all kinds of indicators. It looks super realistic here. You- It's really, really nice to see. And also, we have a very nice GUI here. We do all kinds of arrangements and parameter settings. Yeah, it looks super, super cool right now. Uh, let's talk a little bit about the specific components, maybe. So, we in the simulation environment we have at AWSIM is a Lexus vehicle, right?
Hmm.
It's the base vehicle, and also we have a base sensor suite on top, and the sensor models are in there. And the environment, we have several environments actually. One Shinjuku area from Tokyo, and also we have environment for the in Taiwan where we did the bus ODD and everything. But in that case, you did the track asset reproduction of that environment as well. Give us an understanding of the vehicle dynamics here. Those are super cool vehicles. And what was interesting to work on the Dallara AV21 vehicle dynamics?
Yeah, so when you get to racing and you get to racing at these speeds, 180 plus miles per hour, close to 300 kilometers per hour, the dynamics are very complex and very sophisticated. And, we took our experience that we had from participating in the competition to build a really highly accurate model. And that comes down to the vehicle itself with the suspension. The tires are probably the most important part. The way that tires interact with the ground and create forces. When they're at the limit and past the limit, is very complex to model, and the aerodynamics as well. So with multi-vehicle racing, you're not just out there by yourself. So we also have drafting or slipstreaming aerodynamics models, so that the realism is as good as you have in, say, a racing video game like Assetto Corsa or Gran Turismo, that people are familiar with. We really reproduced a lot of that, but for autonomous racing. This is something that is maybe less crucial when you have lower speed commercial deployments of vehicles, because you're not going to be beyond the limit of the tire. You're not going to be at that limit for 90% of the time. But it's extremely important for racing, and those trickle down effects on improving the modeling will help in commercial applications, especially when you get to edge cases and emergency situations.
Yeah, I mean, yeah, when you do low speed vehicle automation, you really don't need to bother with. That's why usually you use a very simple acronym model, right?
Mhm.
And then that usually suffices at the low speeds, of course. And how about the sensor models? So what type of sensors were on the Dallara AV21 vehicles used on the IAC races?
So the AV21s, they have three RTK GNSS units, so centimeter level accuracy GNSS, which is the primary backbone of all the team's localization, especially at speed. There's three IMUs as well. There's six LiDAR, or three LiDAR, six cameras, and three radar. And for the simulation challenges, um, and the simulator itself, we've replicated those sensors and their interfaces. And so, the exact same interface that the teams are using to communicate, say, with the vector nav GNSS unit on the car. We've replicated that in the simulator, and so basically their same code can be run on both. And we actually, beyond the external sensors, these vehicles have hundreds of sensors on the vehicle itself, whether it's the steering, the engine, temperatures. You have tire pressures, strain gauges on the suspension. There's like hundreds of additional sensors that the teams communicate with through the CAN bus. And so one of the things that we do here is we've replicated that lowest level interface all the way down to the CAN bus level communication, so that the teams can get the sensor data and also send their steering, throttle, brake commands to the vehicle the exact same way they do on the real car.
It sounds like okay. It sounds like battlefield ready. Even to that detail, everything is model. I also didn't know that one. Okay.
Mhm.
How about the track assets? So you kind of send a team to map the environment. Is it more or less the same as what we do for the others, like point cloud map environment, and then creating the Unity assets with some artists or something like that? Can you give us an understanding? And how difficult is it for replicating for the other racetracks if we would like to have them in the sim racing as well?
Yeah, so the way we replicate the racetracks is really important, because we want teams to be able to use it as a tool to practice. And so, if we want them to run the same software in the simulation in the real world, the track needs to be accurate down to the centimeter. And so, what we do is we work really closely with the IAC teams, and they go out and they record centimeter level GPS data of the whole track, both the left boundary and the right boundary in the pit lane. They record onboard video that we use to make the textures and materials, and they also record lidar, so that we have the depth. And so we take all of that data, and at Autonoma we have a really great 3D environment artist that works for us, and we're able to take all that data and turn it into this photorealistic track. And for Monza, because it's such a famous track, and it's
The Temple
beautiful
of
and we're
Speed, right?
races. Yeah, we wanted to make it really, really great. So I mean, we even got to the detail of the tire marks that are on the curbs, and some of these really small details that I don't think anyone would notice, maybe except for us. But we also, do the same thing with other tracks. We've built, the Las Vegas track to help teams participate there, and we do the same things with other environments. And so, really, depending on the application, I think determines the level of realism on the visuals. But for the sim racing, we wanted it to look really good, so we went 100% there. But it's that last a couple percent of realism that probably takes most of the time getting the track surface and the buildings and the tire marks all to look real.
Okay. Uh, it sounds like a very detailed and thorough process. And how is it how it is difficult to replicate for another track? Can you give us an understanding, like in what kind of time frame can you create another track if that was the case?
So, as we've done it with a few racetracks now, we've been able to kind of build up a little bit of a workflow and some assets that we use, and so it's quicker now. But to say to create like the Las Vegas track from scratch with the real team's data, but just to get the track surface, the walls, the pit lane, but not necessarily like the infield or the grass or buildings that don't really have any effect on the racing. That's something that we're able to do in probably about a week now, when
Hmm.
previously it took longer. But to create all the buildings and trees and everything else like we have in Monza, that maybe adds multiple weeks on top of that. So to create something as high fidelity as Monza, maybe 3 or 4 weeks, but it's really something that we've been able to speed up as we've developed these workflows. And with the work that we're doing on the commercial side, industry side, outside of racing, which is more important to us. We've been developing procedural environment generations that we can create environments really, really quickly, almost in real time or same day, with a little fine tuning, so that we can test in all kinds of operational domains and different environments.
It sounds like a lot of people would be also interested to understand, because the times you're talking about, they're very short in my opinion, because we at my company also we created some environments. It takes quite some time, so
Mhm.
it was also nice that you mentioned it. Before we stop the share screen here, the GUI looks really, really nice and very informative. The scenario setup, vehicle setup, sensor setup, and everything. Do you want to mention anything specific here, close to your heart, that you don't want to miss here? Otherwise, I'll just go to my last question for you.
Yeah, I mean, I think with the GUI and the menu, really, from our experience, in the past, what we wanted was something that was really easy for people to just pick up and use. So if you're just using the executable version that's been released, I mean, you just double click it. You in 3 clicks or 2 clicks, you can be running a simulation. And with the vehicle setup and everything we have, we kind of expose a lot of the same variables that the real car has, as far as tuning some of the suspension and other things. And so, we've made it really easy for teams and new teams to get up and running. And then the other thing that's not really shown here, but that we've done for the competition version, is we also have menu bypass modes, and we have command line interface where people can run simulations and do batch simulations at scale to do the tuning of their parameters without having to go through the GUI either. And so, some of the teams have really been taking advantage of that and putting in, hours and hours and hours of tuning, days of tuning. Um, and so, yeah, it makes us happy to see, teams' commitment to even finding that last, half of a second off their lap time.
In an interesting way, this conversation had a lot of resemblance to the previous one, because the previous one we were talking about the cloud environment and the real environment should look as similar as possible, so you make as little
Mhm.
change as possible. So
Mhm.
because it's the simulation. You run batch simulations to validate your things, and when you take all the validated things down to the edge, because you mentioned you modeled everything really really precisely, so it would help the teams out. It was really interesting for me to see that these two topics are actually very nicely connected there too.
Yeah, and for all of our industry work, we've transitioned all of our new products onto the cloud, onto AWS, so that we can run thousands of scenarios, run everything in parallel. and we found ways to make it really, really efficient and economical without having to use, say, really expensive GPU instances on AWS. We found ways that we're able to separate a lot of the core functionality from the rendering, so that for most use cases we can save people a lot of time and expense being able to run thousands of scenarios. So that's really been our focus, recently and going forward at Autonoma, is taking this research level fidelity and making it infinitely scalable on the cloud and making it cloud optimized.
Yeah, totally. Perfect. Before we wrap up, Phil, this session has been very informative and very nice and very exciting because it's about racing. Racing
Mhm.
is bringing a lot of attention. It's making everything popular. But alongside the IAC, do you also have affiliations and works in progress with other things as well? Like Abu Dhabi's A2RL challenge is also uh, being talked quite often
Yeah.
when it comes to the racing, or the F110 as well. F110 is very important at the university side of things for the research, so the students get to know how the autonomous vehicles are working with this kind of little 1/10 scale robots and everything.
Mhm.
Give us also an
Yes.
understanding what you're doing outside of this scope as well a little bit.
Yeah, we're working with two other organizations that are doing really cool, cutting edge, autonomous racing. One of them is with Tier 4 and the JSAE AI Challenge.
Yeah.
That challenge is kicking off shortly, and there's hundreds of participants from around the world that will be competing in that. In connection with Tier 4 and Autoware, so we've been supporting a lot on that, and that's using a very similar base as this open source racing AWSIM that we've created. And then the other thing is the Abu Dhabi Autonomous Racing League. They're doing some really great things, on a global scale as well. And we're working with kind of another initiative that the same organization has to really push this type of opportunities to other universities that maybe don't have the resources, or even really high performing high school students. And so we're working with them on a STEM challenge that uses really fast scaled autonomous cars. So like F110th, but think 100 kph.
Okay.
We're working with them, and with that, the simulation and some of the software we provide is really the base tool set that everyone uses to develop, and all of that is cloud based on AWS, so that really no matter where you are, how many resources your school has, what computer you have, it doesn't matter. You're able to run the same really high fidelity simulation on the cloud, even from your cell phone, if you have to. And so yeah, we're working with those organizations, and really excited to see how autonomous racing continues to kind of push the boundaries and create new technologies that then end up being applied to the commercial space, and also creating really great talent that's coming out of universities to go into the workforce.
Okay, perfect. So thanks for joining to this session, and I want to do another one with Paul Mitchell,
Mhm.
hopefully, and talking about the IAC's vision and everything, and leading to the CES time. There will be probably more information available, how it will look at the CES and everything. And maybe at that point we can also host you back. Maybe you can give us a quick taste of this, what the simulation looks like, because I really didn't expect to see to this extent of detail, but it was really nice for me to see. So uh, thanks for joining again. I hope you enjoyed being here and talking with me, and I hope to see you again sometime soon.
Yep, I appreciate it. Thanks for having me.
Thanks, Will. Talk to you soon.
All right,
Take
thanks.
care.
Bye.